Now, there are different quantities of interest for a particle in projectile motion. So the first one is your maximum height, wherein, of course, given by this one, so that height here is the maximum height, and then, and then, wait lang, there's a question here pala. So, acceptable ba na answer yung x and y component yung final answer? Depende sa context ng problem. If the velocity is what we want, better if you write it as a velocity vector because we're in 2D and 3D. Okay? If the component, if the velocity component lang naman yung hinahanap, wala tayong issues dyan. But if it's the velocity, write it as a component or write it in magnitude direction form. Depende sa context. Case-to-case basis yan. Okay? Question. Did I answer your question? Okay. I hope I answered your question. Now, going back to this this slide, you have different quantities of interest. Tatlo yan. Maximum height, and then the time of flight, the total time the particle is in air, so therefore, mula dito papunta rito, the total time of flight is there, and the range, which is the total horizontal distance the particle has traveled. Okay, now the important assumption here is that the initial and the final vertical displacement of the particle is the same. Dapat parehas yung initial tsaka final y niyan. Pag hindi yan parehas, yung mga equations na kukunin natin dito or i-derive natin, hindi na yan totoo. Okay? Questions? May tanong ba? May tanong? Sige. So, yan. So first, we derive the expression for the maximum height. So what is the velocity and acceleration at the maximum height of a projectile? Kung naalala niyo sa free fall, anong velocity at the maximum height sa free fall? Ano yung velocity at the maximum height?
0.
Yes, 0, exactly. Therefore, we also have the same idea that at the maximum height, the velocity at the y component vanishes. The velocity of x remains kasi v naught x lang naman yan. So, at the maximum height, the velocity looks like that, and therefore, the acceleration is also the same. Magnitude acceleration due to gravity pa rin yan. And therefore, we will impose that at the final velocity, at the maximum height, the final velocity in the vertical component vanishes. So Vy equals 0. So paano natin hahanapin ngayon yan? Edi ganito lang siya. So we have Vy equals, di ba, impose natin na Vy equals 0. Okay, what we want is height. Let h be height such that Vy equals 0. Then, wala tayong time. Di pa natin alam yung time. Ano pwede nating kinematic equation na gamitan? We know our maximum height. And initially, we have a particle V naught y equals to V naught sine alpha naught. Right? So in that case, paano to? We use velocity position. And for velocity position, we have Vy squared equals to V naught y squared minus 2g quantity y minus y naught. Now, at h, at y minus y naught equals h, Vy equals 0. And so this is V naught y. And this means that 0 equals V naught sine alpha naught quantity squared minus 2g h. Tama? And therefore, h is just equal to V naught squared sine squared alpha naught over 2g. Tama? Tama? Thus, we na obtained our maximum height equation. This is equation 7.9. Tama? Nakuha? Nakuha to?
Opo.
Okay, nakuha. Now, that's the first expression that we want. So, the maximum height, the question now is what initial angle gives the greatest maximum height? Kailan nagma-maximum yung height mo? At what angle? At what angle? It will be maximum, yung V naught hindi mo mababago yan. Yung G, of course, hindi yan nagbabago unless nung lumipat ka ng planeta. But the only one that can change is your angle alpha naught. Therefore, what angle will give us the maximum height? Ano? So dito, sine, remember, kailan maximum ang sine function? At alpha naught. Yes, at pi over 2 radians or at 90 degrees. Hence, the maximum occurs at sine squared alpha naught is 1, where alpha naught is 90 degrees. So when you plot the trajectory of a projectile in different initial angles with the same initial velocity, we will see that at alpha naught equals 90 degrees, which represents your free fall motion, the pinakamalaki yung maximum height. Okay? Questions? Questions?
None po.
None. Okay. Now, okay, what about the time of flight? What about the time of flight? The time of flight, as I said, is the time for the particle to be in air. The total time the particle is in air. So yon, from the start to the end point, urasan mo yan, yun yung time of flight. Then their assumption here, as I said, is dapat initial and final height sila parehas lang. Dapat parehas lang yan. So, ang itsura ng projectile natin ay ganito. Okay? Now, balikan natin si trajectory equation. Naalala nyo, di ba, na parabola ang trajectory equation. Therefore, kung parabola yan, dapat may axis of symmetry yan. Di ba? So therefore, at this case, yung time it took for the particle to reach the maximum height, tapos, equal siya mula dun sa maximum height pababa. Kasi symmetric yan eh. By symmetry, we can use that argument. And therefore, ang pwede natin sabihin is the total time of flight the particle is in air is just twice the time for the particle to reach its maximum height. Therefore, if t is the total time of flight, this should be equal to th, where th is the time to reach the maximum height. Tama? Tama? Pero remember, alam natin yung condition for maximum height. That is, at the maximum height at h, vy equals 0. And therefore, we can use using velocity time kinematic equation. We see that vy equals v naught y minus gt. And at h, this is 0 equals v naught sine alpha naught minus g th at the maximum height. Ito ay time at maximum height. And therefore, this means that th is just v naught sine alpha naught over g. And hence, since the total time of flight is twice nito, we will get this expression na dapat may factor of 2 dyan. That's 2v naught sine alpha naught over g. Tama? Nakuha? By the way, this is a different derivation compared to what's written in the annotated lecture slides. Ibang pagkakaderive ko nito. It's much simpler. Okay? Questions? Questions? May tanong?
None po.
Okay. Now, so the total time of flight, or I will use capital T for the total time of flight, pero it uses T flight pala rito, but I use capital T. Okay, so what initial angle gives the greatest time of flight? Again, it's independent for a constant V naught and G. Ano yung angle? Siyempre, kung saan maximum yung sine. Therefore, the maximum occurs at sine alpha naught equals 1. And if we plot it, dapat at 90 degrees ulit yan. So, pinakamatagal yung travel ng particle at sine alpha naught equals 1 at 90 degrees. Okay? So, therefore, at 90 degrees, the trajectory, dun siya pinakamatagal. Pinakamalaki yung time of flight. Okay? Question? Question? May tanong? None. Okay. Now, finally, we have range. What about the range? The range is just the total distance traveled by the projectile from its initial to its final position with the assumption that they are at the initial and the final vertical displacements are equal. So, the horizontal distance, range is the horizontal distance from the projectile's initial position to final position. So, that's the range. And again, the assumption here is that this initial displacement and final displacement, they have the same y coordinate. Y, pares dapat yung y niyan. So, kung saan siya umakyat, doon siya bababa. Okay? In terms of y. Now, pero paano nakahanapin yung range? So, therefore, the range is just the total horizontal displacement at the time of flight. And we already know our time of flight. So, So again, so therefore the range is just the total velocity multiplied by the time of flight t. But Vx here is what? Vx is what? That's the initial velocity in the x direction. This is just V naught x times t. Parehas lang yung initial tsaka final velocity at the x direction. So this is just equal to V naught cosine alpha naught multiplied by what? 2 V naught sine alpha naught all over G. Tama? Tama? And hence, the range is just 2 V naught squared sine alpha naught cosine alpha naught all over G. Now, recall that sine 2 theta equals 2 sine theta cosine theta for some angle theta. Tama? And thus, we can write our range as V naught squared sine 2 alpha naught over G. That is the equation for your range. Tama? Tama? Nakuha to? Gets? That's the formula for your range. So yan. So meron ka ng tatlong equation. So what angle gives the greatest range? Dito na nag-iiba. Kasi hindi necessarily maximum at 90 degrees ang sine of 2 theta. In fact, hindi siya 90 degrees. So, kailan lang siya nagma-maximum? Nagma-maximum to at alpha naught equals 45 degrees. Therefore, at 45 degrees, we will see here, dun pinakamalaki yung range. Tama? Questions? Are there any questions? May tanong? Are there any questions? Wala? Walang questions? Now, in summary for this topic here, we have 3 different quantities of interest. We have now an expression for the maximum height, the total time of flight, and the total range. Okay, these are the equations that you need to familiarize if you want to solve problems in projectile motion. Okay, are there questions? So, may tanong ba?
None, sir.
None, okay. Sige. Now,